Alright, morning grade 12s. Today we're going to be having a look at the mean and variance of a binomial distribution. What you need to know there is that our expected value is our mean, and that we can find by saying mu is our expected value, which is n times p. Our variance is also sigma squared, and you'll remember from last year we could find that out as e of x squared minus e of x all squared. But when we're working with binomial, we can actually find sigma squared as npq, which means that your standard deviation, which is your square root of your variance, is npq. All right, let's have a look at how we can apply that. A test consists of 20 multiple choice questions, each with 5 alternatives for the answer. A student has not studied for the test, so she chooses the answers at random. Remember, you need to always define your variable. So we're saying let x be the discrete random variable that describes the number of correct answers. Okay, in this case we've got 20 questions, so our n value is going to be 20, and for each question you've got 5 alternatives. It's a multiple choice binomial. It's either correct or it's not correct, and your probability of getting a question correct is 1 in 5. Okay, now we've already established that this is binomial, so we can say x can be approximated by a binomial in n and p. X is approximated by binomial 20 and 1/5. It now says determine the expected number of correct questions answered. So our expected value is also going to be our mean. So what we're interested in is e of x, which is equal to n multiplied by p. So we've got 20 times 1/5, which is equal to 4. So you're expecting to get 4 out of 20 when you're guessing multiple choice questions. Don't do it. Therefore, we expect 4 correct answers. Okay, determine the standard deviation of the correct number of questions answered. Well, we know that standard deviation is the square root of n, p, and q. Remember that q is going to be 1 minus p, so that will be 4/5. So we have the square root of 20 times 1/5 times 4/5, and that gives me 80 over 25, and that's approximately 1.7889.